Woohoo! We are live, and this is Sharktopus and me helping you with fractions as common factors. Woohoo! And I know a lot of you were saying, we can't make factoring any more fun, and yet we can, and we have, because we're going to mix factoring with fractions. I mean, tell me this isn't perfect. So, in order to get into this, I want to do a very quick, little tiny review of fractions. Specifically, what happens when you multiply a whole number like 7 times a fraction like 1/4. So generally speaking, you don't have to follow all the steps. I'm just going to follow, the formal steps. And those are that if I'm going to multiply a whole number times a fraction, first thing, I'm going to take the whole number and write it in fractional form, because that makes it easier for me to see who's on top and who's on the bottom. And then remember that what we do is we multiply across the top and across the bottom. Sorry about that, Sharktopus. And so if I multiply 7 times 1/4, I get 7/4, which is kind of convenient. So then next, what I want to talk about is what happens if I start out with 7/4. If I start out with 7/4, assuming I know how to draw 7, I'm also allowed to use this information, the fact that I know it works this way. Equals go in both directions, right? It's not just a one-way street. It goes both ways. So if I start with 7/4, and then there's a bunch of stuff in the middle, I happen to know that that equals 7 times 1/4. These two expressions have equal value. So whenever I see 7/4, I could split that up as 7 times 1/4. I can use substitution to replace one of them with the other. Okay, so that's where we're going to start with. Now, where I'm going to go ahead and factor this polynomial, I'm making this video for multiple different levels. So you may find that I'm going to do more steps than you would do. You are welcome to skip the steps that you think are unnecessary, but I just want to be really thorough. If I'm going to factor a polynomial, the first thing I'm going to look for is common factors. And in order to do that, I'm actually going to take this polynomial and write it out really long, really expand this, write everything out. Don't write anything, short with special symbols and stuff. So I'm going to explicitly write out all of the exponents, all of the powers here. And I'm going to write the fractions. So I've got 3/4. That's going to be 3 times 1/4. Then I've got x squared, so that's xx. Then I've got a y, and then z cubed, z. Next up, well, this is just 1/4, so I'm going to leave it as 1/4. I don't have a number on top that's different than 1. I've got x, y squared, that's y, and then a single z. Now here I've got 5/4, and just like I did up here and just like I did with the first term, I'm going to split this up. 5 times 1/4, x squared is x, and z is just z. I don't know why I wrote in the multiplication there. Sometimes it just comes out of me. My hand gets excited about writing multiplication, as I know many people do. Try to get rid of that little stray mark there. Okay, so our goal in factoring out common factors is merely to do pattern matching. I want to figure out who's the same in each term. So I happen to see that I've got a 1/4 in each term. And so I'm going to factor out the 1/4. Next up, I've got some x's. Now here I have to take a look. I've got 2 x's, I've got 1 x, I've got 2 x's. So you try to take out as many as you can, but you can't take x's that aren't there. So if there are 2, and then just 1, and then 2, I can only take out one. That's the only thing they have in common. So they don't all have 2, so I could just take out the 1x. So I factor out the 1x. Next up, the y's. Now, I'm very excited. I've got, a y here and some y's there, but I don't have any y's in the last term. And so that says I'm not going to be able to factor them out. Now, your brain may say, wait a minute, there are a bunch of y's, take a y out. If it doesn't exist in one of the terms, you're toast. It's just unfortunate. Now let's look at z's. Here I've got 3 z's. I've got 1 z and 1 z. Ooh, 1 z, like, 1 z. I can take out 1 z from each term. So if I've taken out 1x and a 1/4 and one of the z's, what do I have left in the first term? I've got a 3, one of the x's, the y, and 2 z's. Then I've got a minus, right? And then I take out the 1/4, I take out the x, I don't take the y, so I've got a y and a y, and then I did take out the z, so that's all that's left in there. And then I've got a plus. Now I take out the 1/4, that leaves the 5. I take out 1x, so I've got 1x left, and I take out the z. So all that I've got left here is 1/4 xz times, let's see, inside 3xyz squared minus y squared plus 5x. Now, sometimes you may be asked to write it like this, to kind of write these two more compactly, write the x and the z on top of the 4. That's just like this when we have the 7 times 1/4, but sometimes we snug the 7 up on top of the 4. So this is a possible answer, and this is a possible answer, and then I have to include this expression, what's in the parentheses. So, and then my last step is to just check. I've got a 3. Nobody else has a 3. I've got an x. Well, these two have x's, but this term does not. I have y. These two terms have y's, but no y there. And then z's. Nobody else has z's. So there's nothing else that's common to all 3 terms. So we are done. You have done it. That is factoring out a common fraction in addition to all the other common factors. Woohoo! You guys are awesome. Math on.